All right, let's talk about one of the most fundamental concepts in flying, turbulence. Have you ever been on a perfectly smooth flight and then, out of nowhere, it feels like you're on a roller coaster? Well, that's what we're diving into today. We're going to pull back the curtain on this invisible force and show you exactly what's happening just outside your window.
You know the feeling, right? One minute you're sipping your coffee, the next, that fasten seatbelt sign dings on, and you're gripping the armrest. It might feel totally random, but there is absolutely a science to it. See, the sky isn't as empty as it looks, and today, we're going to learn how to read its invisible currents.
So our mission today is pretty simple. We're going to turn you into a kind of turbulence detective. By the end of this, you'll have a simple toolkit to understand what's going on, so the next time you're in the air, you can actually look out the window and spot the signs. Ready to get started? Let's do it.
Here's our flight plan. First up, we'll tackle a big question. Why do planes get bumpy in the first place? Then we'll get to the heart of it, the three main culprits behind turbulence. We'll break down each one: turbulence from heat, from obstacles, and from something called wind shear. And stick around, because at the end, we'll put your new knowledge to the test with a quick quiz.
Okay, let's get right to it. To really make sense of turbulence, it helps to have a simple map. Instead of thinking of it as one big, confusing mystery, it's much easier to see it as three distinct things.
And here's our map. Pretty much all turbulence can be traced back to one of these three sources. First, you got heat from the sun causing the air to rise. Second, you have physical obstacles, like mountains or even big buildings, just getting in the way of the wind. And third, you have different layers of air clashing with each other, moving at different speeds. And that's what we call wind shear.
So let's start with the first one, and probably the most common cause: heat. This is that classic bumpiness you feel on a warm, sunny day, especially when you're flying a little lower to the ground.
The official name for this is thermal turbulence, and it's all about convection. You can picture it like bubbles rising in a boiling pot of water. The sun heats the ground then heats the air right above it, and since that warm air is less dense, it starts to rise up in these invisible columns. For an airplane flying through all this, it's basically hitting invisible speed bumps in the sky. It flies out of a smooth patch of air, straight into one of these rising columns, and then back out again. That's what gives you that familiar jostle. Pretty straightforward, right? Okay, now for our second category. What happens when a nice steady flow of air runs smack into something that won't move, like a huge mountain? Well, let's find out. This is called orographic turbulence. When a strong wind hits a mountain, it has no choice but to go up and over. But, what goes up must come down. So on the other side, the lee side, which is the downwind side, the air comes tumbling down, creating this chaotic, swirling mess. It's a lot like water rushing over a big rock in a river. Now here's where it gets really interesting. Under just the right conditions, this tumbling air doesn't just create random bumps. It can actually organize itself into a really powerful, totally invisible, and potentially very dangerous phenomenon that we call a mountain wave. So what does it take to cook up a mountain wave? Well, the recipe is very specific. First, you need a pretty strong wind, at least 25 knots, hitting the mountain almost straight on. Second, that wind has to stay strong or get even stronger as you go up. And finally, you need a layer of stable air right around the mountain's peak, which acts like a lid, trapping the energy. This is exactly why pilots have a ton of respect for mountain waves. We're talking about massive up and down drafts that can literally pull a plane down faster than it can climb. And here's the really scary part. If the air is dry, the wave can be completely invisible. It can also create these dangerous rolling pockets of air called rotors down low. All right, so we've covered heat and we've covered obstacles. Let's tackle our third and final category, turbulence from wind shear. This is what happens when two different chunks of air just refuse to play nice with each other. The key word here is change. Wind shear is a sudden, sharp change in wind speed or direction over a really short distance. Imagine two currents in a river flowing right next to each other but at different speeds. That boundary between them would be a mess of swirls and eddies. It's the exact same idea in the air. We can break this down into two main types. You have vertical wind shear, which is a change in wind as you climb or descend, and you have horizontal wind shear, which is a change as you're flying straight and level. Both can cause turbulence, because when a plane flies from one block of air into the next, its wings are suddenly hit with a totally different force. So where do you find this stuff? Well, a really common place is near weather fronts, where you have cold and warm air masses colliding.
Another spot is at the top of a temperature inversion, where you have a layer of cool, still air trapped under much faster winds. You can even get it when local winds, like a sea breeze, clash with the main wind flow.
Here's a perfect real-world example right from the textbook. Think about an airport like Zurich, which is in a valley. At night, cool, foggy air can settle on the ground, but the wind just a few hundred feet above that fog might be moving much faster. So when a plane takes off or lands, it passes right through that boundary and experiences a sharp, sudden kick from the change in wind. That's vertical wind shear in action.
Okay, so we've looked at the three big causes separately: heat, obstacles, and wind shear. But in the real world, the sky can throw more than one of these at you at a time. So let's quickly put it all together.
In reality, a pilot has to be ready for anything. Think about it. On a single flight, you could take off from a hot runway and get some thermal bumps, then cross a mountain range and hit orographic turbulence, and then as you're coming into land, encounter wind shear. It's all about reading the conditions and knowing what to expect.
All right, you've got the theory down. Let's see how you do with a quick quiz. First question. What do we call the turbulence that's created when wind gets forced up and over a mountain range?
If you said orographic turbulence, you are absolutely right. And remember, the key is that it's most intense on the lee side, the downwind side, where all that air tumbles back down. Great job. Okay, question number 2, and this one is really important for safety. True or false? Mountain waves are always visible because they create those cool lens-shaped clouds. What do you think?
And the answer is a big, critical false. This is such a vital thing to remember. Yes, those unique clouds are a fantastic warning sign, but if the air is too dry to form them, a powerful and dangerous mountain wave can be completely invisible. It's a powerful reminder that sometimes the biggest forces are the ones we can't see, and knowing what causes them is the first step to safely navigating the sky.